All right, and hello everyone. Today we're going to be looking at solving logarithmic equations. Two types of questions we're going to be focused on today. Type one is going to be when we have a log equals a logarithm. Basically, the goal in these questions is to get log of something equals log of something. You might have to do a little bit of cleanup to get there, but basically, once you have a log equals a log, you just cross out the logs and set the arguments equal to each other and solve. So for the most part, these aren't too bad to solve. It kind of depends what you have going on the inside, but for the most part, there shouldn't be anything too crazy. But one thing you do have to be careful about with all of these logarithmic equations is you can get extraneous solutions. You don't really need to plug them in and check if both sides, what they actually equal. Really, we're just focused on the argument. You can't have an argument equal a negative number. And just remember the arguments like what's in parentheses or the big text size on the side with the log. But basically, you can't have an argument equal a negative number. So for this example, if I have log of x minus 3, 6 would be good because 6 minus 3 is positive 3. But for example, 2 would not be valid since it would give me a negative result when I plug it into here. And in equations, especially these first types, you're going to have multiple logs. It just has to happen in one log. So if one of the logs equals negatives, it's extraneous. It doesn't have to do it for both. Sometimes it will, but just has to happen once. The reason this is true, if you're like wondering why, it's just if you change this into log form, if you remember the base is 10, we're saying 10 to what power equals x minus 3. There's no way to get a power, like any number up to a power will never equal a negative number. Because if you remember, negative exponents just give you a reciprocal. So you just can't have a negative argument. Like there's no way to make that exponential form ever equal that. That's the reason why. But let's just look at some examples. So there's, I believe, three of these I left blank. I worked out the rest, so you're welcome to look at those. But so for this first one, I already have the logs equal logs. There's no funny business. I don't have multiple logs on one side or anything like that. So for this first one, or number two, just cross out those logs, set the arguments equal to each other. And we just need to solve. Depending on your equation skills, feel free to do a couple steps at a time. Like I would probably add the ends to the right just to avoid a negative. I would subtract the 43 if you could do this in kind of one swoop if you want, because then I would get negative 42 equals 6n. Divide this. I would get negative 7. So that's my answer. Like I said, I should check if it's extraneous. And all you need to do is just check. If I plug in negative 7 into either one of these arguments up top, do I get a negative result? And you should see both of them are fine because the 1 minus negative 4 times negative 7, that's going to be positive because the double negatives. Even the second one, even though I'd have negative 14 plus 43, it's still going to be positive. So this one's good. Like I said, you don't actually need to solve or figure out what it equals as long as you can tell if it's positive or negative. Zero is okay, by the way. You can have zero, just no negatives. And that's our answer. That's basically the idea with these. Example six, though, just to show you, if you have multiple logs, you're going to want to condense them into a single log. So you want to get it in, make it look like questions one, two, and three. So like for this one, if you remember, a minus causes us to divide our argument. So 68 divided by 4 would be 17. Oh, and don't forget, I mean, that doesn't really matter too much for these. So now this looks like questions one, two, and three. Now I can cross out the log part and set these arguments equal to each other. And sorry, I don't have a lot of space. I would subtract the 11 over, I'd get 6. Divide by 3, I should get 2. And like I said, just check if any of these arguments would equal 0. If it's a number, obviously, there's nothing that's going to change. So like these ones are fine. And if I plug 2 into that 3n plus 11, no problems. It's going to be positive. So that's valid. Um, just to show you one, number 3 had an extraneous because I got my answer was 6. But if I plug 6 into, say, here, even this first one, 6 minus That would be 18, 3 times 6. That's a negative result, so that's why this is extraneous. It also doesn't work for this one, but like I said, it only has to not work once for it to be extraneous. All right. If you flip to the back, just showing you an example with number 10. Like I said, if you have something you need to condense, like remember a plus means you multiply the arguments. Oops. So that would just be 2k squared. And this one, just copying it over. Now we can get rid of the log parts if the arguments equal to each other. I'm just going to move that k squared over. So I would get k squared equals 16. Square root, don't forget when you square root um, both sides of an equation, you should get the positive and negative. I'm just going to separate these because a lot of times you might see one of these as extraneous. But actually, in this case, we're okay. Because, like I said, we have 3 logs we should check in the original. Like I said, if it's a number, you don't really need to check it. But 4 squared is positive, negative 4 squared is positive. So this one's not a problem. And same thing, k squared plus 16, that's going to be positive. So actually, both of these work. We have 2 solutions, but just be careful. A lot of times when you have a plus or minus, one of them might work, one of them might not. So a lot of times I even write my answers separately, just so I can check them. So that's type 1. Let's look at type 2. Type 2 is where you have just a singular log equals a number. And the big idea is we're going to just basically change these into exponential form and solve. If you don't remember, exponential form is this, the base up to the power equals the argument. If you don't remember what those pieces in the log form, you can reference that below. So let's look at question 12. So one thing is, if you have any extra stuff like things added or subtracted outside your argument, remember your argument's always going to be, should be in pretty much always parentheses, unless it's a single number. Sometimes they don't. But we got to add this 7 over before we do the process in this question. So if we did that, I would get positive 4. So like I said, we're going to change it into exponential form. So I'm going to take my base, 3, up to my power, which is 4, and then set that equal to the argument. And then you just need to solve this. 3 to the 4th, use a calculator, especially if you need to, but 3 to the 4th should be 81. And then just solve this equation. I kind of wrote too big. You would subtract the 8 over, that would give you 73 divided by 4. I believe that's the answer. Let me just pause and double check my key. All right, and sorry, I just paused it to double check my key, and yep, that's correct. And that's not extraneous because it won't give us a negative. All right, just one more question we're going to look at. Same thing, like I said, we do want to condense if we have multiple logs. So we have a plus. So remember, that means we're going to multiply these arguments. So we'll have log, and we got to distribute basically that x. So that'd be x squared minus 3x equals 1. Remember, if you don't have a base, remember it's base 10. So we're going to take 10 to the first power equals our argument. So that would just be 10. And I'm just going to go ahead, especially if you have a quadratic, you're going to want to get everything to the same side. So we'll have this. Sorry, I'm writing too big. Luckily, I got more space. Then you would factor this. This would be minus 5 plus 2. So I'd get 2 solutions. I'd get 5 and negative 2. We do need to check if either of those are extraneous. So like I said, we're looking at the original, really just the left log. Well, actually, misspoke. Sorry about that. Actually, we do need to check both. We have x minus 3 and then x, right, for my arguments. So 5 is fine, right? 5 minus 3 is positive. 5 is positive. So this one works. But for the second one, negative 2, like negative 2 minus 3 is negative, or just negative 2 is negative. So this would be extraneous. So just a single solution. So hopefully this helps. Today or Monday and Tuesday, if you're watching this, I'm just going to have you work on this concept. So we'll see if we can get these down. Let me know if you have any questions.